Okay, so this is going to be lesson 4.7. Arithmetic and geometric series. That handwriting is horrible. Let me get my pen out. Arithmetic and geometric series. Okay. A series is an indicated sum of the terms of a sequence. I'll explain what that is in just a second. So a series is an indicated sum of the terms of a sequence. So if I were to write the numbers 1, 2, 3, 4, 5, you don't need to write this down, yada, 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 20, 21, and I said, tell me what the sum is of the numbers between 4 and 20. Well, you could sit there and you could go 4 plus 5 plus 6 plus 7 all the way up to 20, and you could add them that way, right? But what if the numbers get really big? What if I said add the numbers between 100 and 300? Well, you're not going to sit there and do it 100 plus 101 plus 102. Plus, like, that's just going to take forever, right? So instead, we have a formula that we can use so that we can just figure out what's the first number, what's the last number, and we can add those together and do a kind of a funky formula that's going to give us what those would add up to. All right? So it says arithmetic series, arithmetic when we think about adding and subtracting, is written by this formula up there. S sub n. So S means sum, all right? N means the number of terms. So that N, let's write that somewhere out to the side. N means the number of terms. So how many terms are there? Number of terms. So how many numbers are you adding together? Okay. A1 is the first number in the sequence. And A sub n is the last number in the sequence. So,
N, you said? A sub n?
yes, A sub n is the last number in the sequence. So if we look at some of these examples here, it says find the sum of the first 100 positive integers that there are. So that would be like 1 plus 2 plus 3 plus 4 plus 5 plus 6. Like, that's going to take forever for us to look at. So instead, we're going to use this formula. So when you're doing this formula, I want you to think about each of those three pieces that we listed. A sub 1, A sub n, and n. All right? So in this example, what is the n? How many numbers are between 1 and 100? Don't think too hard.
99.
No. 100. Okay? Between 1 and 100, there are 100 numbers, right? So our total number of terms are going to be 100. I have 100 terms. Okay? A sub 1 is, what's the first number in the sequence?
1.
Number 1, right? If we're starting at number 1. And then what's the last number? 100. If you do these three things each time, you should have no problem plugging this into the formula. Okay? So my formula says S sub n, well, how many terms are there?
100.
So we're going to do S sub 100. That just means the sum of the first 100 numbers equals, what was our n value? 100 over 2. And then we're going to add A1, which was 1, plus our AN, which is 100.
What does it mean to put the number in the subsection?
It's just the label of it. Yep.
So it's the same number, just in the position?
Correct. So it's just saying, what's the label? So this S sub 100 right here just means that's the sum of 100 numbers. Okay. All right, so 100 divided by 2 is 50 times 100 plus 1 is 101. And if I do 50 times 101 in my calculator, what do you get, Olivia? 5,050. Anybody else get the same thing?
Yeah.
So that would be the same as if someone sat over here and did 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100. Isn't this formula a much faster way of doing that? Right? Okay, questions about letter A, example A, using the formula?
So we're just trying to find the amount of possible combinations in this,
Nope.
or
No, I'm not doing anything with combinations. It's a faster way of adding numbers together. Bless you. Of adding numbers together. Right? I don't want to sit there and go 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 100. That's
So
going to take forever.
So how do we get 5,050 out of 100 then?
You divide the 100 by 2, which is 50. Then you do 50 times 101, and then you get the amount.
Because trust me, if you were to sit there with your calculator and go 100 plus 99 plus 98 plus 97 plus 96 all the way down to 1, you would get 5,050.
So okay, so the sum is asking us to multiply all.
Okay, so let's look at example B. So they already give you your A1, your AN, and your N, right? So they're telling you there are 8 terms, that's N. There are 8 terms between 7 and 79. So we don't know how they calculated the terms. We don't know if they multiplied by 5 to get the next one. We don't know how they got those 8 terms or what those 8 terms are, okay? But it's asking us to find the sum of these 8 terms if the first one is 7 and the last one is 79. So let's go ahead and do this. So we have our S sub 8. There are 8 terms. We do N over 2. That's what my formula says. So N is going to be my 8 over 2 times my first number, which was 7, plus my last number, which was 79. Okay, so use your calculator. Kate, I'm coming to you with the answer. Did you get the answer already?
Oh, I put 72 instead of 79.
Oh, okay. Make that adjustment. And then put it in your calculator and let me know what you get. $344. Anybody else get 344? Yep. Good. Okay, try letter C, please. Yep, that's all you're doing. Now, there is a little bit of a catch on the next part, but we're not there yet. Try letter C. Braxton, what'd you get? 1,501. Anybody else get the same thing? One other person, too?
I was heading up.
You're okay.
15, 20, what's the what?
Did you do you have 158 for your sum? Times 9.5 or 9.5?
Well, I had 160, 115 plus 45, 43.
Yeah, there you go. You're on the right track.
I got 589.
Did you do 9.5 times 158?
No.
Okay, so then you wouldn't get the right answer. You got to
Wait,
follow
how
the
did you
formula.
get 158 of that?
Okay, so then we have this fancy character, this E looking thing over there. It's really the Greek letter sigma, okay? And sigma means sum. That might be a bonus question. Sigma means sum in math. So we're using sigma notation. All right, so it's going to look a little bit different, but we're still going to use the same process and the same formula. If you look over here at this formula, it says the first value of n is going to be below the sigma notation. So that's your A1 is going to be there at the bottom. Your AN is going to be there at the top. The value of n you're going to have to calculate, and I'll show you how to do that. But then you're going to have to send the A1 and the AN through the formula. And I'll show you how we're going to do that, okay? So the first thing that we're going to do is figure out how many terms. So it says here, we go from 5 to 8. How many numbers are from 5 to 8? Be careful. If we just subtract, we get 3, right? But if we count on our fingers, 5, 6, 7, 8, how many numbers is that?
4.
It's actually 4 numbers. Okay, so if you want to think about this, you can subtract. 8 minus 5 is 3, but then always add 1 back in because you're counting the first and the last, okay? So I have 4 terms, so my n is 4. So again, if I count on my fingers, 5, 6, 7, 8, that's 4 terms, okay? What is our A1, Leanna? Where does A1 come from?
The first value.
That bottom number, right? So what's the bottom number on our sigma?
5.
Yes, good.
Is that what J is?
J, okay, so J is just the letter. Yep. You can just kind of ignore that it's the letter for right now. So our A1 is 5. But here's the thing. Remember I said you have to send it through the formula? So that's when it's talking about J is that number. So we have to send it through the formula first before we actually get what our A1 truly is. So if I were to put 5 in for my J value, right up here, okay, I'm just putting 5 in for my J value. I get 15 minus 4. And what is 15 minus 4?
11.
So that's my true A1 value that I'm going to use.
So you're not going to use 5.
Correct. I'm not going to use 5. I'm going to use 11. Then we're going to do the same thing for our A sub n. What's our A sub n initially? What's the first number that it is? 8, right? It's that top number. But again, we have to send 8 through the formula. So 3 times 8 minus 4. 24 minus 4, 20. So this is my real AN that I'm going to use.
So we basically put both numbers in place of J.
Correct. Yep. So now that I have a new A1 and a new AN, now I get to use the formula from up top. Go ahead and write this down on your paper so you remember where you go next. And now you're going to plug it in like normal, okay? So using the new A1 and the new AN value.
And still 4.
Yes, N is still going to be 4. That one does not change. Good. The N value is still 4. A1 changed to be 11. AN changed to be 20.
Oh, we have to put the 4 by the S, like you do?
You mean as like the label?
Yeah,
You don't have to, but. Okay, so 4 divided by 2 is 2 times 31. What is 2 times 31?
62.
Good. So S sub 4 is 62. Do you guys want to try letter E on your own?
Yeah.
Okay, try letter E on your own. Do the same process. If you're watching the video, go ahead and pause and try letter E on your own. Okay, so this is what this looks like, and then we're going to do 4 times 28. Samantha, what do you get?
112.
112. Who else has 112 as their answer, or you're quickly on your way there? Okay. Any questions about that one? What do you do with the what? 8. Okay, so remember you do 10 minus 3, right? Which is 7, but then you have to add 1 back in, right? Because if you were to count on your fingers, 3, 4, 5, 6, 7, 8, 9, 10, you'd get 8 terms. Okay. All right, so the process is the same as long as you have a sigma. Once you have a sigma, though, remember you got to throw it through the formula first and then plug in for your A1 and AN, okay? All right, let's look at geometric series. So with geometric series, the pattern involves using geometric patterns, which means you're actually going to be closer to what we would consider multiplication, okay? So we're going to get a different formula for geometric. Now, on your test, under your homework, you don't have to guess whether it's arithmetic or geometric, okay? You also don't have to memorize these formulas. You just have to know how to use them, okay? So you're going to get the formulas on your test and your final exam, and it's going to tell you whether it's an arithmetic series or a geometric series in your homework and on your test, okay? So you don't have to guess which one is which, but you need to know how to do them, okay? So if we're looking at this formula, we see some things that are the same, right? We see our S sub n. We see A1. What does A1 represent? The first number, right? So we know, let's go ahead and write that out. We know that A1 is the first number in the sequence. We know that N is the number of terms. But if we look in this one, what is our R?
That's new.
That's new, right? The R is new. So R we're going to think of as the rate at which the pattern is increasing or decreasing. Okay. Counting your 2 parents, your 4 grandparents, we're not talking steps, just your 4 grandparents, your 8 great-grandparents, and so on, gives you a geometric series where you start with 2 people, right? You're starting with your parents, 2 people. And your R is 2. That means it's doubling each time. How many ancestors do you think you're going to have after 15 generations? So let's throw out some guesses before we figure this out. After 15 generations, how many ancestors do you think you're going to have?
30.
After 15 generations? Crystal says 30. Cade, what do you say? 400. Anybody else want to give it a go? Samantha, what are you thinking? 50? Oh, 15? We already have like 15 up there.
About 3,000.
3,000. Anybody else? Okay. 600? All right, let's check it out. Okay, so let's look at our formula. S sub n, it says find the number of ancestors going back 15 generations. So here our n value is 15. Okay? So we're still finding the 3 things. So we need an A1, we need an N, and we need an R. They tell us our A1 is 2 because that's how many we're starting with. Your parents, that's 2 people. And it's going at a rate of 2 people. Okay, so now we're going to plug this into the formula that we have. So we have S sub 15 equals our A1, which is 2, times 1 minus 2 to the 15th power. You guys see that? Your R value, which is 2, raised to the n, which is the 15th power. Okay? All divided by 1 minus your r value, which is 2. Okay, so in your calculator, I want you to do 2 to the 15th power. And you're probably going to be using this button right here that looks like a little caret, 2 to the 15th. Or if you have the y to the x button, that's going to be your 2 to the 15th. Okay? Everybody's doing it on their calculator, so you can do 2 and then yx 15, if that's you. Question. So when we do 2 to the 15th, we're getting like 32,000 something, right? What are you guys getting?
32,768.
1 minus 32,768. Please write it in your formula just like this. We just did 2 to the 15th. I didn't do negative 2 to the 15th, just 2 to the 15th. And then in the denominator, what is 1 minus 2? Negative 1. So let's just put a negative 1 in the denominator. So that we don't make any mistakes, let's be very careful. When I do 1 minus 32,768, I'm really getting negative 32,767 divided by negative 1. 1 minus 32,768.
How did you
Keep
get
change,
out of
change.
that?
how do I what?
How did you get a negative out of that?
Because
If you
the
take
num-
1 and you subtract 32,000 from it, if you have $1 but you owe me 32,000, you're going to be in the negatives.
Okay, yeah.
Big time. Okay, and then let's do 2 times 32,767.
65,534.
5,000 or 500 what?
34.
We know this is a negative, and we know this is a negative 1. And what's a negative over negative?
Positive.
So I get 65,534. That's how many ancestors you have going back 15 generations. Now, we were pretty close with our guess of 3,000.
Pretty close.
I'm teasing, being sarcastic, right? So, and I love doing this problem because I know what the answer is, and so when I hear students are like, oh, 50 people. And I'm like, you are so not even close. Okay, 65,534 people, or ancestors. Let's write that out, ancestors. That's a lot of people. And that's not even counting aunts and uncles. That's just grandparents. Great, 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 great grandparents. Okay, so let's just try letter B with just some numbers. Okay, so try letter B with just some numbers. Be really careful with your positive and negatives, okay? So we have our N, that A sub 8, cross that out, that should be your N.
So what's
Wait, hang on just a second. Let me look. Okay, so there's an error on your paper, okay? You can cross this out right here, this 384. What this should have said is that your N value is 8. Okay?
Did you get the answer?
No, 384 is not the answer. Okay, so cross that out, that your N value should be 8. If you're watching the video, go ahead and pause and try this one on your own. We have to be really careful with our negative signs because sometimes that can trip us up. Okay? Any questions on letter B? All right, let's try letter C. On letter C, we do need to be really careful about our positive and negative signs, okay? So go ahead and set letter C up, but you notice your R value is what? It's negative, okay? So when we set it up, we have to be really careful. So if I set up S sub 5 equals 4, 1 minus negative 3 to the 5th. Look at how I've done this here. Okay? I put the negative 3 to the 5th in parentheses. And then I have 1 minus negative 3. Now, when you use your calculator, if you do this in your calculator, it's going to always apply the negative after it does this. But in our calculator, we want to do parentheses negative 3, close your parentheses, to the 5th. Okay, so you all have parentheses on your calculators. Put negative 3 in parentheses first, and then raise it to the 5th power. What is negative 3 raised to the 5th power?
Negative 243.
Negative 243. Anybody else get negative 243? Okay, so notice that our formula is already 1 minus, right? Negative 243. Be really careful here.
No, I thought we turned both into positives.
So if you do that, you're going out of order of operations. You're not following order of operations if you do that first, because there's an exponent there. What is 1 minus a negative 3 on the bottom?
-2.
Be careful. Now you can do the keep, change thing, right? 1 plus 3 is really 4. So Taylor, we are allowed to change the signs down here on the bottom because notice there's no exponents, right? It's just 1 minus negative 3. So let's make life a little bit easier. You guys see I have a 4 on top and a 4 on bottom?
Cancel.
We can cancel those out. So now I just have 1 minus negative 243. And what do I do with that? What is 1 minus negative 243?
-242.
Okay. Plus, plus, right? You change the signs.
Oh, I thought we couldn't do that to this one.
Okay, the reason we couldn't do it back here, was because of this 5. This 5 was there, and that's an exponent. In order of operations, say you have to do exponents first. So if I did plus plus here, that would not be following order of exponents, order of operations, okay? But here I have no more exponents, so I can do change. And so I get 244.
Wait, so that number was in a parentheses once it was taken to the 5th power?
You don't have to use parentheses, but you need to make sure you have 2 negative signs. So that's why I put it in parentheses.
It keeps it organized.
Yes. Yep, that's going to be your final answer. Okay. Now what happens when we have sigma notation? So here's the thing. Your A1 is going to be in the same place there at the bottom. Okay, your A1 is going to be there at the bottom. Wait, I'm sorry.
No, I was gonna
Sorry, let's back up. Your A1 is here. This number in front. It's the first number you see. Your R value is going to be what's being multiplied. And we're going to find N the same way we used to, right? So if you look at example D, remember to find N, we would have to do that 6 minus 1. You guys remember doing that to find your N? How many terms? And then you would add 1 back in. So between the numbers 1 and 6, how many terms do you have?
6.
You have 6 terms, right? If you counted on your fingers 1, 2, 3, 4, 5, 6, you would get 6 terms. Okay, or if you did 6 minus 1 is 5 and you added 1 back in, you're still getting 6. So our N value here is 6. If we look at this again, our A1 value is here, which is what? No. What's your A1 value? 5. And your R value is 2. Good. We are, at this point, we are not worried about this over here. Okay? We don't have to worry about the N minus 1. Now guys, there might be a problem that looks like this. Sigma notation, if you have 4 and then 10, and then you just have 3 raised to the n plus 1. If you look at this one, there looks like there's no number out front right here, right? It doesn't look like there's any A1. What number might always be there, we just don't write it? 1, okay? So in this event, there would be a 1 out here. That would be your A1, all right? So whatever is being raised to the exponent, that's your R value. So now that we have our values, let's go ahead and use our formula like we had to before. We don't need to put it, we don't have to kick it through any formula. So I can say S sub 6, my A1 value, which was 5, times 1 minus 2 to the 6th, over 1 minus my R value, which is 2. Say that again. Okay. Our formula at the top says S sub n equals A1, 1 minus R to the n, over 1 minus R. So if we use that formula, S sub 6, our A1 value is 5. 1 minus 2, which is our R value, raised to the n, which is 6, over 1 minus 2.
So in a sigma notation,
We don't have to send anything through a formula. We just have to identify it differently. Okay? It's going to be identified differently.
yeah, that makes that easier. than
Okay?
the other one.
Go ahead and work this one out. You do not need a negative when you square or when you take your 2 to the 6th power. You do not need to put a negative in there. Just take 2 to the 6th power. If you're watching the video, go ahead and pause and try this one on your own. Okay, take a minute and check your work. Anybody have any questions? All right, try letter E on your own. Be careful because your R value is negative. Be really careful. Pause and try on letter E on your own. As we're going through this, 1 minus 729 is negative 728 over 4. Can I reduce 2 over 4?
Yeah.
You can, right? And if you didn't do it, it's fine. But 2 times negative 728, negative 1456,
52.
56, divided by 4. Braxton's paper says 360 what? 364. Does anybody else get negative 364?
Yeah.
Equals S sub 6. So yes, it is possible to get a negative number. It is possible to get a negative number as you're doing this, but you have to be really careful when your R value is negative. Questions about this, guys? All right, in your packet you have 12 problems to do on page 24. So we're going to take just a few minutes, about 15 minutes, work on page 24. Guys, on number 1 on page 24, look at number 1. It lists the numbers out, right? So when you're looking for your A1 on number 1, what is your A1 on number 1?
4.
4, right? It's the first number. What's your A sub n there?
29.
29, okay? And then how many terms are in the sequence? How are you supposed to find out what n is? How are you supposed to find out what n is?
Mine.
You can count them. Thank you, Samantha. You can count those numbers to figure out how many terms are in the sequence, okay? So some students get to that problem and they think they don't know how to do any of it, all right? You just count the numbers. Samantha?
I didn't hear the first part.
So your A1 is your first number. So what's the first number there?
4.
And then your AN is your last number there,
Oh, okay.
okay?
First and last.
Yep, and notice it says arithmetic, so I would put my arithmetic sequence or my arithmetic series formula right there at the top. Then when it goes to geometric, I would also put that equation formula there at the bottom.